To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. I'm going to continue with the lesson current electricity. So in the previous chapters, we discussed what resistors are, the three types of resistors, fixed value resistor, variable resistor and light dependent resistor. And also we discussed the factors that affect the resistance of a conductor. The length of the conductor, cross-sectional area of the conductor and the material that is used to make the conductor. And in relation to all those, we did activities. So you're familiar with what resistors are. And then you're familiar with Ohm's law, V equals IR. When the potential difference is a constant value, say you have a power source, a power pack or dry cells with a certain potential difference. According to the Ohm's law, V equals IR. So because of that, when the resistance of a circuit increases, the current flow through the circuit will decrease, or vice versa. If you decrease the resistance, the current flow will increase. So that means if you want to control the current flow through a circuit, you will need to have or use resistors. You are familiar with that concept also. You have seen how we use rheostats. When we try to observe the relationship between potential difference and current to test Ohm's law, we used rheostats, a variable resistor. So there you all know the function of a resistor. By changing the resistance, you can change the current flow. So to do that, we will need different values for resistors. So if you need different resistors, we did that type of activity also. We can use a 5 ohm resistor, 10 ohm resistor, 20 ohm resistor. Like that, we can use different values of resistors. But let's say we don't have a particular resistor. Say we need a 12 ohm resistor, whereas we don't have an exact 12 ohm resistor with us. So then we need to have a way of providing that resistance to that circuit. To do that, we can use combination of resistors. So if we have different resistors with different values, we can combine them in two different ways in order to get the resistance that we require. So when more than one resistors are combined, the value that comes out as the combination of resistors is what we call as the equivalent resistance. So one resistance value that is equal to the output of all the resistors connected in a circuit is what we call as the equivalent resistance. So to get this equivalent resistance, there are two ways of combining resistors. That is what we call as combination of resistors. So resistors are used to control the current passing through a circuit as desired. So that is what I explained to you all. So you all know this. Resistors are used to control the current passing through a circuit as desired. And when it is difficult to find a resistor with the required resistance, it is possible to use many resistors to obtain the required value. So that is what I said. The required value is what we will be calling as or referring to as equivalent resistance. To get that, we can combine resistors, and that can be done in two ways. There are two basic methods of combining resistors. So if we look at the two methods, first one is known as series combination of resistors. Series combination of resistors. And the second method is known as parallel combination of resistors. Parallel combination of resistors. You're familiar with these two types of combination also. You can remember how we connect ammeter and voltmeter. Ammeter, if you want to measure the current flow through a particular component, a device in the circuit, you have to have the ammeter in a series manner. It has to be continuously connected. The same way, if you want to measure the potential difference, you all know how you connect the voltmeter. If you want to have the potential difference between 2 points, the voltmeter should be connected parallelly. So similar to that, we can connect resistors in a series combination or in a parallel combination, or else both these can be combined together as well. So to understand that combination, we will discuss these two methods one by one, and then we will try to understand how we can calculate the equivalent resistance. So with that, students, I'm going to move on to the next slide. The first one is series combination of resistors. So when the resistors are connected in such a way that the same current flows through each of the resistors, it is known as a series combination of resistors. That is the important part. You have to understand that. Now, when the resistors are connected in such a way that the same current flows through each of the resistors. So that's very important. The current does not change. So we provide a potential difference to the circuit so that it can drive the current flow. The current flow through all the resistors will be the same. So that means if the resistors are different, the potential difference will also vary. I will explain that. So to understand that, consider 3 resistors R1, R2 and R3 connected in a series combination. So I will draw the circuit first, then I will explain how it functions. So we will need the circuit with 3 resistors. So you know the symbol for resistors. Either you can use these zigzag lines or you can use a rectangle. That is for a fixed value resistor. So we are going to use 3 fixed value resistors, R1, R2 and R3. So here we have R1, R2, R3. You can write it in the same line or we can write it as a subscript. This is just to denote the resistors. So it is up to us to use the symbol. Then here I will have the power source, the dry cell. So this is going to be the potential difference supplied by the dry cell, and also we will have an ammeter here. So you know why we use an ammeter? To measure the current flowing through the circuit. So since this is the positive terminal, the negative terminal, you all know the direction of the current flow. How will it flow from the positive terminal to the negative terminal through the circuit? So this is going to be the direction of the current flow. Now this combination where you have the resistors one after the other connected in the circuit is what we call as the series combination. So in this combination, the current flow is going to be the same value. How is that going to happen? Now from the positive terminal, current flows through this and there is only one path for the current to flow. So current flows in this direction. Here the same current through all the resistors and it flows back to the dry cell. So the same current will flow through all the resistors. Then if we write the equation for Ohm's law. What is that equation? V equals IR. So V equals IR. Now I is the same, but R1, R2, R3 are going to be different. So what do you all think about potential difference V? Will it be equal to this V? That is the potential difference across the circuit. That is all three resistors together. So the total potential difference is going to be V. But that potential difference will be divided between these three resistors. So if we take 3 points, between these 2 points, it's a potential difference across R1. Then similarly, across R2, there will be a potential difference. And across R3 also, there will be a potential difference. And the sum of all those potential differences will be equal to this V. So we can consider the potential difference across R1 as V1, potential difference across R2 as V2, then potential difference across R3 as V3. I'm sure you all can understand that. V equals IR, I is not going to change, R is different, therefore the potential difference is also divided across the resistors. And you have to remember, students, if the resistors are equal, if they have the same value, same magnitude, then the potential difference will be divided equally. Otherwise, depending on the value of the resistor, the potential difference also will vary. We will look at some more examples after we discuss this concept. So then, if we are to calculate, so potential difference across resistor R1. So that will be equal to V1 is equal to I into R1. Why? I is the same across all the resistors. So I is the same across all resistors. Because of that, we take it as I. Then potential difference across resistor R2. That will be equal to V2 equals I into R2. So then, if we write the potential difference, runs across resistor R3, that will be equal to V3, that is equal to I into R3. Is that clear, students? If we quickly go back and have a look, now you can look at the circuit. The three resistors are connected in a series manner, and the current flow will be the same value. All the current that is flowing through the circuit will flow through R1, R2 and R3. That will not change. So that means the potential difference, voltage, will be distributed across the three resistors. So across R1 V1, across R2 V2 and across R3 it is going to be V3. Then from the equation of Ohm's law, V equals IR, we come to these three equations. Potential difference across resistor R1 will be equal to V1 equals I into R1. Potential difference across resistor R2 equals V2 equals I into R2. Whereas potential difference across resistor R3, that is equal to V3 equals I into R3. So from these three equations, we can come to an equation to calculate, or we can get an equation to calculate the equivalent resistance. I will do that in the next slide. So here, when resistors are connected in series, the sum of the potential difference across the resistor is equal to the supply voltage difference. So that is what I told you all. The potential difference V, that is the supply voltage difference, that will be equal to the sum of potential differences across all the three resistors. That is what I denoted as V1, V2 and V3. So from that, the equivalent resistance is the resistance of a single resistor that could be used in place of all three resistors. This is something you all have to remember, students. What equivalent resistance is? The equivalent resistance is the resistance of a single resistor that could be used in place of all three resistors. Very important. So that is the equivalent resistance. Now we will see. So according to this, potential difference V is equal to V1 plus V2 plus V3. That means from V equals IR. So you can remember, students, we already wrote the equation for V1. V1 is equal to I into R1. The current does not change. So I into R1 plus V2 was equal to what? Again I into R2. So V3 is equal to what? I into R3. Now look at this. If I write it again with I into R is equal to, I will take this I as the common factor. So I into R1 plus R2 plus R3. So on either side you have IR, here I into R1 plus R2 into R3. So I can be cancelled off. So you get R as equal to R1 plus R2 plus R3. If we write that here, from this equation, you can get the relationship R is equal to R1 plus R2 plus R3. Why? You can cancel off both the I's. I on either side. So this R is what we call as the equivalent resistance. R is the equivalent resistance. There are three resistors, R1, R2, R3, and those are the resistance values. And the equivalent resistance. What is equivalent resistance? The equivalent resistance is the resistance of a single resistor that could be used in place of all three resistors. So here we have three resistors, R1, R2, R3. Instead of that, you can use one resistor with the resistance value of R. So that is what we call as equivalent resistance. And then in a series combination of resistors, the equivalent resistance is equal to the sum of all the resistors. So this is the equivalent resistance. that is equal to the sum of all the resistors. So here, that is very important. This is an equation that you all have to remember, students. An important equation. I will show you all an example. Now we will take so if we have a circuit like that with 3 resistors, let's say there is a potential difference of 6 volts, then there is a current flowing, and here you have 3 different resistors. Let's say we have resistors with equal magnitudes 2 ohm, 2 ohm, 2 ohm. Now if you are to calculate the equivalence resistance, what is the equation we use? Here equivalence resistance is equal to R1 plus R2 plus R3. So there are 3 values. What is R1? Equals to 2 ohm plus R2 is 2 ohm, R3 also 2 ohm. So the unit is 2. What is the sum of all the resistors? The resistance of all the resistors, 2 plus 2 plus 2, so 6 ohms. The equivalent resistance of this particular circuit is 6 ohms. So if you calculate the current flow through the circuit, V is equal to IR. From that you can calculate I is equal to V over R. What is V? Potential difference 6 volts. What is R? 6 ohms. So current is going to be 1 ampere. And this particular 1 ampere current will flow through all the resistors. Through this also 1 ampere, through this also 1 ampere. The same current will flow through all the resistors. To understand this further, now we said, no students, the equivalent resistance now you can remember the equivalent resistance is the resistance of a single resistor that could be used in place of all 3 resistors. So we calculated the equivalent resistance as 6 ohm. So if you have a circuit with 6 ohm resistance and 6 volt potential difference, what is going to be the current I? Like we calculated here. It is going to be the same value. From V equals IR, you can get I equals V over R. So here you directly have the potential difference 6 volts, resistance 6 ohm. So you will get the current as 1 ampere. I is going to be 1 ampere. So now can you all understand? That is a 6 ohm resistor, the same potential difference, the current flow is 1 ampere. Here we have 3 2 ohm resistors. But when they are combined in a series manner, they give an equivalent resistance of 6 ohm. Why? The equivalent resistance for series of resistors is the sum of all the resistance. Therefore, 2 plus 2 plus 2, we get the 6 ohm resistance. And the current flow is also going to be the same value. So that is similar to the equivalent resistance. Is that clear, students? So what happens to the potential difference? Now here, potential difference across these 2 points is going to be 6 volts. So if you consider the potential difference across all these 3 resistors, we will again label them as R1, R2, R3, just for us to identify, because all the values are the same. So I want you to identify them separately. Now, if we look at the potential difference, the 6 volts is for these 2 points across all 3 resistors. That is why we calculated the current flow through all the resistors using the equivalent resistance. So that means the potential difference will be divided across the 3 resistors. So if we calculate that, now if we calculate potential difference across the resistors R1, R2 and R3. So then across R1, V equals IR. What is the value? We calculated I as 1 ampere. 1 ampere into the resistance 2 ohms. So that will be equal to 2 volts. Then across R2. So here also we will label these as V1, R1. Then it is easy for us to identify. So here V2 equals, I will not change, R2. That is how we wrote the equation before also. You can remember that in the previous slide. So here again, 1 ampere, the same current flow. The resistance is the same. So that is also going to be 2 volts. Same for the third one. Across R3. That is going to be V3 equals I into R3. That again 1 ampere into 2 ohms, that is 2 volts. So now can you all understand how the potential difference is divided across the 3 resistors? The values of the 3 resistors are equal, so the potential difference is also divided equally. You all have to understand that. Is that clear, students? So if you understood this, we will look at another example where the 3 resistors that are connected in series combination have different values. So I will explain that as well. Three different resistors connected in a series combination. We need to have 3 resistors with different values. So again, here also we will take the potential difference as 6 volts. Current I, that is the same current that is going to flow through all the resistors. This I will take as R1 equal to 1 ohm. R2 equals to 2 ohm and R3 equals to 3 ohm. Now you all can see, students, 3 resistors connected in a series combination, but the current flow through all the resistors are going to be the same. It is current I. Through this also current I. Through this also current I. That will not change. But the potential difference here, that is going to be V1, V2, V3. Now earlier the resistors had equal values, so the potential difference was also equal. But here the resistors have different values. So according to the resistors, the potential difference is going to vary. We will see how that happens. Now what is the equation we use to calculate equivalence resistance? Equivalent resistant R is equal to R1 plus R2 plus R3. So R1 1 ohm, R2 2 ohms and R3 3 ohms. If you add them together, how much? 1, 2, 3. So it is 6 ohm. Like earlier, the equivalent resistance is the same, 6 ohms. So what is the current flow? V equals IR. From that we get I equals to V over R. So potential difference 6 volts divided by equivalent resistance 6 ohm. So 1 ampere current. Is that okay? Equivalent resistance is 6 ohms. Current flow is 1 ampere. So through all the resistors, I is going to be equal to 1 ampere. So I is equal to 1 ampere. 1 ampere current will flow through all the resistors. But the potential difference is going to be different. We will calculate that. We'll say potential difference across R1. R1 is what? 1 ohm. So V1 equals I into R1. That is equal to I 1 ampere and resistance 1 ohm. So the potential difference is going to be 1 volt. Then potential difference across R2. That is V2 equals to I into R2. That will be 1 ampere, same current. Current does not change in a series combination of resistors, but the resistance is different, 2 ohm. So here 2 volts. Then potential difference across R3. That is equal to V3 equals I into R3. I is the same, 1 ampere, but R3, you all know, is equal to 3 ohms. So that is going to be equal to 3 volts. Now can you all see the relationship? We have resistors. we have three resistors, R1, R2, R3. 1 ohm, 2 ohm, 3 ohm. Current flow is the same. I is the same. But the potential difference is distributed across the three resistors. In what manner? 1 volt, 2 volts, 3 volts. So the ratio between the resistors is 1:2:3. Look at the ratio between the voltage differences, potential differences. 1:2:3. So depending on the resistors, the potential difference is also distributed. Less resistance, less potential difference. More resistance, more potential difference. Why? Because the current flow is the same through all the resistors when they are combined in a series manner. You all have to understand this, students. We will quickly go back and go through all the values. So from this, you were able to get the equation for equivalent resistance. We had 3 equal resistors with 2 ohms. There also we calculated the equivalent resistance as 6 ohms and the current flow as 1 ampere. So that is similar to having a resistor with 6 ohms there. That is what we call as equivalent resistance. Then, when we calculated the potential difference, you can understand, you understood this. Potential difference V1 across R1 is 2 volts. Across R2, that is potential difference V2 is also 2 volts. Across the third resistor, that is also 2 volts. So there, all the resistors have equal values. So the potential difference is divided equally. And the current flow is the same magnitude, same current through all the resistors. That is in a series combination. Then, we looked at an instance where we have 3 different resistors. R1 1 ohm, R2 2 ohms and R3 3 ohms. So here also the current is the same. Potential difference 6 volts, we calculated the current 1 ampere. But you all know the potential difference will vary. V1, V2, V3. So we calculated the equivalence resistance first. Sum of all the resistors, 1 ohm, 2 ohm, 3 ohm. So that is also 6 ohms. Then we calculated the current flow, V equals IR, I is equal to V over R. Here we use the full potential difference across the circuit. Potential difference supplied by the dry cells. 6 volts divided by 6 ohms, the current is 1 ampere. Then, if we calculate the potential difference across R1, V1 equals I1 into R1. So, 1 ampere into 1 ohm, potential difference 1 volt. Potential difference across R2, that is V2. Potential difference 2 is equal to I into R2. I is the same. So, 1 ampere current into 2 ohms, potential difference is 2 volts. Then, the potential difference across R3, that is V3 equals I into R3, 1 ampere, 3 into 3 ohms is equal to 3 volts. So from that, I am sure you all can clearly understand, depending on the resistors, according to the ratio between the resistors, the potential difference will also be divided. So that is what you have to remember. So when the resistors are equal, the ratio is also 1:1. 2 ohm is to 2 ohm, 3 ohm is to 3 ohm. So accordingly, the potential difference will be divided equally. But when you have different resistors, according to their ratio, the potential difference is also divided. That is what happens in a series combination of resistors. So I'm sure you all would have understood this clearly. Now I'm going to move on to the next slide and discuss an example with you all. Example 1. The figure shows a 10 ohm resistor and a 2 ohm resistor connected to a 6 volt power supply. So look at the diagram, students. Here we have a 10 ohm resistor. Here we have a 2 ohm resistor. They are connected in a series combination. And here you can see a power supply of 6 volts. So in this, you already know that the current is going to be the same. The same current I will flow through 10 ohm as well as 2 ohm. So here, but the potential difference will be distributed according to the resistors. So this is going to be V1, this will be V2. That is how I am going to denote them. Potential across 10 ohm resistor is V1. Potential difference across 2 ohm resistor is V2. But the sum of V1 and V2 will be equal to 6 volts. That you have to remember. That also we saw in the previous examples where I explained this clearly to you. So V1 plus V2 will be equal to 6 volts. And same current I through 10 ohm and 2 ohm. So those are the things that you already know. We'll look at the questions. Find the equivalent resistance of the system. So we need to find the equivalent resistance. What is that? R. R is equal to what? Sum of the resistors connected there. The resistance of the resistors connected there. Since there are only 2 resistors, we will write it as R1 and R2. That is equal to 10 ohm plus 2 ohm. So the equivalent resistance is going to be 12 ohms. 12 ohm is the equivalent resistance. Is that clear to you? Sum of the resistance of the 2 resistors, 10 ohm and 2 ohm. And the equation, you know, R is equal to R1 plus R2. If we have 3 resistors, you add R3. But here there are only 2 resistors, so R is equal to R1 plus R2. That is the equivalent resistance. Then the second question. What is the current passing through the circuit? The current passing through the circuit is I. The same current will pass through the 10 ohm resistor and the 2 ohm resistor as well. So if we calculate the current, V equals IR. So I is equal to V over R. What is the potential difference? 6 volts. 6 volts through the circuit. That is the potential difference across the circuit, across both the resistors 10 ohm and 2 ohm. And the equivalent resistance here is 12 ohms. So what is the current? 6 divided by 12, that will be 1 over 2, 0.5 amperes. A current of 0.5 amperes will flow through the 10 ohm resistor and the 2 ohm resistor. You all have to understand that, students. So those are the 2 questions. That is what you need to calculate. Now, in addition to this, I want you all to calculate the potential difference across the 10 ohm resistor and the 2 ohm resistor. We discussed it before. what is it? The potential difference will be divided according to the ratio between the resistors. So 10 ohm is a higher resistance, then the potential difference across the 10 ohm resistor will be greater. Whereas the potential difference across the 2 ohm resistor will be small. So you all can try that first. As a note, I will do it. If the potential difference across the resistors are calculated separately, then potential difference across the 10 ohm resistor. What is that going to be equal to? I said V1 equals I into R1. So there, what is I? We calculated the current as 0.5 amperes. And what is the resistance? 10 ohm. 0.5 amperes into 10 ohm. 0.5 into 10 ohm, that is going to be 5 volts. So V1 is going to be 5 volts. Then potential difference across the 2 ohm resistor. That is V2 equals again I into R2. When we write the equation again and again, students, I am sure you all can understand, you will get it clearly that the current does not change through the resistors when they are connected in a series combination. So V2 equals I2 into R2. That will be equal to what? I, the same value, 0.5 amperes. And what is the resistance? 2 ohm. 0.5 amperes into 2 ohms. What is that? 0.5 into 2, 1 volt. So can you all look at the values? 5 volt across the 10 ohm resistor, 1 volt across the 2 ohm resistor. So what is the total potential difference? Total potential difference V equals V1 plus V2. So 5 volt plus 1 volt, 6 volt. So in the diagram also, you can remember in the question, the potential difference of the power supply, the die cell, is 6 volts. So that 6 volt potential is distributed across the 2 resistors. 10 ohm is the higher resistance, 5 volts. So like I told you all students, the ratio. Resistors R1 is to R2, 10 ohm is to 2 ohm. So if you get the ratio, 5 is to 1. And the potential difference was 5 volt is to 1 volt. So now can you all understand the relationship? This is for you all to check or for an MCQ when you want to do it quickly, you can use this. But when you are to write the answers, show the calculation, you have to use this method. You have to show the equation, you have to write the equation, you need to show the substitution and do the calculation. But to quickly get the answer, you can use this ratio. And also you can use this to verify your calculation, to check whether your calculation is correct. Now is that clear to you all students? We have resistors combined in a series connection. The current flow is the same. The equivalent resistance is the sum of all the resistors. Therefore, according to the magnitude of the resistance, the potential difference will be distributed. If the resistors have equal values, potential difference is divided equally. If the resistors have different values, then the potential difference is divided or distributed according to the ratio. More potential difference for the higher resistance. Less potential difference for the lower resistance. But the current flow will be the same. Those are the things that you need to remember or you need to understand in relation to this series combination of resistors. Again, I will go back up the slide and we will go through the calculation. So this was the question. The diagram was given to you, 10 ohm, 2 ohm, 6 volt, current I wrote these two as V1 and V2. So from what we already know, we know that V1, V2 should be equal to, sum of them should be equal to 6 volts. And the same current I will flow through both the resistors. That is how the series combination works. Then you were supposed to find the equivalent resistance of the system. So R is equal to R1 plus R2. That is the equation. Then if you substitute for R1 and R2, 10 ohm and 2 ohms, the equivalent resistance is equal to 12 ohms. Then the second question, what is the current passing through the circuit? So you use the equation V equals IR, I is equal to V over R. V is the potential difference across the circuit. That is both the resistors together or the potential difference of the power supply, 6 volts. And the equivalent resistance is 12 ohms. So 6 volt divided by 12 ohms, you get the current as 0.5 amperes. Then as an additional information, as a note, I showed you all how to calculate the potential difference across the two different resistors. Note, if the potential difference across the resistors are calculated separately, then you will have this calculation. Potential difference across the 10 ohm resistor will be equal to V1, that is equal to I into R1. 0.5 amperes current and 10 ohm resistor. So the potential difference is 5 volts. Then here, potential difference across the 2 ohm resistor, that is V2 is equal to I into R2. 0.5 amperes into 2 ohms, that is equal to 1 volt. If you take the total potential difference, V equals V1 plus V2, 5 volts there and 1 volt here. That is equal to 6 volts, the potential difference of the power supply. So from that, you all can understand that the potential difference is divided according to the value of the resistors. If the resistors are equal, potential difference is also divided equally. If the resistors are different, then it will be divided according to their resistance. So this is like an additional knowledge to you all. If you understand this clearly, you can always use this using the ratio to check your answer or to come to your answer quickly. But like I told you all students, if you all are to write the answers, that is for the paper 2, you have to write the equation, you have to substitute and show the working as well. Then only you should write the answer. This is like a shortcut method that you can use it for your convenience, but not to do it on the paper. You have to keep that in mind. So I'm sure students, now you all have a good understanding as to what series combination of resistors are. So with that, I'm going to end this chapter, and in the next chapter, I will discuss how we can calculate the equivalent resistance of resistors combined in a parallel combination.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.